In this video, we will take a look at the graphs of trigonometric functions. In senior forms, we have learned the concept of functions, and we can also treat sine, cosine, and tangent to be functions. For y equals sine x, we call this a sine function. For y equals cosine x, we call this a cosine function. For y equals tangent x, we call this a tangent function. Before we take a look at the graphs of trigonometric functions, let's come back to the definitions of sine, cosine, and tangent. We have learned that sine theta is equal to the y-coordinate over r, cosine theta is the x-coordinate over r, and tangent theta is the y-coordinate over the x-coordinate. In particular, when r is equal to 1, we call this a unit circle. A unit circle is an important concept in trigonometry, because when the radius is equal to 1, then sine theta is just equal to the y-coordinate, and cosine theta is just equal to the x-coordinate. By considering a unit circle, we can understand the graphs of trigonometric functions in a better way. Now let's take a look at the graph of the sine function. In a unit circle, the value of sine theta is just the y-coordinate of this point. That means the length of this line segment is the value of sine theta. And on the graph, we can capture the value of sine at this value of theta in this way. And now I can change the value of theta and capture the graph of this sine function. When theta is in the third quadrant, sine is negative, and same in the fourth quadrant. This is the graph of sine theta for theta between 0 and 360 degrees. If we extend the range of theta to be less than 0 degree and greater than 360 degrees, the graph of the sine function will be like this. Now as you can see, the value of the sine function increases and decreases periodically. It has a repeating pattern which will continue forever. Now let's take a look at the graph of the cosine function. In a unit circle, the length of this red line segment is the value of cosine theta. Therefore, we can now capture the graph of the cosine function in this way. When theta is 0 degrees, cosine theta is 1. Therefore, the function starts at 1. In the second quadrant, cosine is negative. Same in the third quadrant. And then in the fourth quadrant, cosine will become positive again. This is the graph of the cosine function when theta is between 0 and 360 degrees. If we extend the range of theta, the graph will look like this. Now as you can see, the shape of the cosine graph is exactly the same as the sine graph. The only difference is that cosine starts at 1, while sine starts at 0. Finally, let's take a look at the graph of the tangent function. The value of tangent is actually equal to the length of this line segment. In a unit circle, the length of this line segment is equal to the value of sine theta over cosine theta. Geometrically, this line segment is a tangent to this circle. Therefore, we call this trigonometric ratio the tangent ratio. Now we can try to capture the graph of the tangent function in this way. The tangent function also starts at 0, like sine. Now tangent will keep on increasing, it can be extremely large. In the second quadrant, tangent is negative. And then in the third quadrant, tangent will become positive again. And then in the fourth quadrant, tangent will be negative. This is the graph of the tangent function when theta is between 0 and 360 degrees. If we extend the range of theta to include any angles, the graph will look like this. Now as you can see, the graph of the tangent function is not continuous. That means the lines are broken. Now let's put the pieces together. For these three graphs, we need to know about its domain, y-intercept, x-intercept, the maximum value, the minimum value, and the period. Let's take a look at this one by one. The domain for the sine function and the cosine function is all real numbers. However, for the tangent function, as the graph of tangent is broken and the broken points cannot be part of the domain, therefore the domain is not all real numbers. For the y-intercepts, the sine function and the tangent function has the same y-intercept 0. And that means the graphs pass through the origin. On the other hand, for the cosine function, the y-intercept is 1. For the x-intercepts, the sine function and the tangent function again, they have the same x-intercepts. For the cosine function, the x-intercepts are similar. Compared with the sine function and the tangent function, the x-intercepts of the cosine functions are all shifted towards left by 90 degrees. For the maximum value and the minimum value of the function, the sine function and the cosine function have the same maximum value of 1 and the same minimum value of -1. For the tangent function, there is no maximum value and no minimum value. It means that tangent can be extremely large, and at the same time it can be extremely negative. For the period of a function, it means a minimum duration of x after which the pattern of the graph will repeat itself. For the sine function and the cosine function, they have the same period of 360 degrees. That means the pattern will repeat itself after each 360 degrees. On the other hand, for the tangent function, the period is shorter. It is just a half of the period of the sine function or the cosine function. That means in the tangent graph, the pattern will repeat itself more rapidly. To understand these features better, we may put the graphs together. Here the blue one is the sine function, the red one is the cosine function, and the green one is the tangent function. Now as we can see, the tangent function is discontinuous or broken at x equals 90 degrees, 270 degrees, 450 degrees, etc. These values of x are exactly the x-intercepts of the cosine function. This can be explained by the identity tangent x equals sine x over cosine x. When the denominator cosine x is equal to 0, tangent x will be undefined, and therefore the graph is broken at the points when cosine x is equal to 0. On the other hand, when the numerator sine x is equal to 0, tangent x will also be 0, and therefore tangent x and sine x, they have the same x-intercepts. And therefore the tangent function and the sine function intersect with each other along the x-axis. On the other hand, we can see that the graph of y equals cosine x is just the graph of y equals sine x after translating to the left by 90 degrees. And also we can see that the period of the tangent function is half of that of the sine function and the cosine function.